These notes will be on quadratic and parent functions, and we're finding domain and range. So we're recalling this information because we did learn this earlier in the year when we looked at linear functions, and we're identifying domain and range. So when you look at the parent function, it means that this is the origin of it. This is where it began. So just like you have parents, your parents have parents, well, the quadratic function has a parent function, and for our parent function, it's y equals x squared. For linear, it's y equals x. And so you went through that origin, and it was up one, right one. And so now for quadratics, it's y equals x squared, because squared indicates it's a quadratic function. So your shape of your graph is a parabola. It's a U-shaped graph, whether it's facing up or facing down. Your domain is not restricted. Your domain is the x values. So when you look at this graph and you look at the x values, when there's an arrow at the end, that means your x values are not restricted. So the domain is going to be all real numbers when you see the parent function. The range is the y values. So when you look at the parent function, it starts at 0 and goes up. So the range is going to be y is greater than 0. This is just for your quadratic parent function. Now we're going to look at different graphs of quadratic functions, and we're going to identify the domain and range after being moved from the parent function. So here's two examples. We're going to start with the example on the left. So we're going to find the domain first. The domain is your x values. So when I look at this graph, I want to automatically recognize if I'm looking for the domain is x. There are arrows at the end of my graph. That means my graph goes on and on and on in both directions. So none of my x values are restricted. So we say that the domain is all real numbers. Another way to abbreviate that is using an R with two lines. Now we're going to look at the range. When you look at the range of the function, you're looking at the y values. So when you look at the y values, you look from bottom to top. Well, in this case, they start here at the bottom. This is the lowest value of the y values. So you go to that lowest point in the graph, and you ask yourself, since this is going up, it's including all of the values greater than or less than -3. Well, all of the values above are greater than. So to write the range, you're saying y is greater than or equal to, because it lands on a solid line, to -3. So your range in words would be all real numbers greater than or equal to -3. Now let's look at another example. Now we have a graph facing down. If we want to identify the domain, you want to look at the ends of your graph. If the ends of your graph have arrows, that means that the x values are not restricted. They go on and on and on in both directions. So since the x values are not restricted, that means the domain is all real numbers. The range are the y values. When you look at the range, I'm going to look at the top of my graph now. Because my graph is facing down, my parabola is facing down, the very top of my graph is going to be at +9 for the y values. And it's on the graph, it's on the line, so it's including that point. So that means I ask myself, are all the values below here greater than or less than 9? So if they're including all the values below, y is going to be less than or equal to 9. So your range is included 9, and you say that in words, all real numbers less than or equal to 9. So when your graph fades down, it's a less than or equal to symbol. When your graph is facing up, it's a greater than or equal to for the y's. Now let's look at two more examples. Here, your graph is facing down, and it has arrows, so we should automatically know that the domain is not restricted. Your x values are not restricted, so the domain is all real numbers. The range, if I look at the highest point of this graph, this point's going to be at -3 for the y values. And if it's going down, then it's including all of the values that are less than -3. So because this is facing down, its y is less than or equal to -3, the y value from that highest point. So in words, all real numbers less than or equal to -3. And one more example. you have a graph facing up, and again, you want to recognize that there are arrows at the end of your graph. If there are arrows, then that indicates that your domain is all real numbers. For the y values, since your graph is facing up, you go to the lowest point in your graph, and that's at -4. And you ask yourself, are all these values above? Are they greater than or less than -4? Y is going to be greater than or equal to -4 because it lands on this point and it's including it, and they're greater than or equal to. So your range in words is all real numbers greater than or equal to -4. Now let's go on to some examples where you have open and closed circles. That's when your domain will change and so will your range. So we've seen these examples before, but we're going to refresh our memory. So now, because on this graph, there are no arrows, we cannot say the domain is all real numbers. There's open and closed circles, so we need to remember what that means. So first, let's look at the domain, which are the x values. When you look at the domain, you always look at your graph from left all the way to the right side of your graph. So you ask yourself, where does this graph begin on the left? This graph begins at -3 for the x values, and if I follow it, it ends at +2. So for domain, if your graph, you're looking from left to right for domain. On the left, our x's are beginning at -3, and they're ending at +2. Since we're talking about domain, that's x values. Now we just have to figure out which inequality symbol should we use. Well, at -3, it's a closed circle, so we need to use a less than or equal to. At +2, it's an open circle, so you need to use a less than symbol. So in words, what this means is all real numbers greater than or equal to -3 and less than 2. Now let's go ahead and identify the range, the y values. So when you look at the range, the y values, you always look at your graph from bottom to top. So I'm looking here at the bottom of my graph, and at the bottom of my graph, they begin at -7. And I follow this all the way to the top of my graph. The top of my graph ends at +2. But I want to recognize that both of these are closed circles because on a line is a closed circle and this is a closed circle. So for your range, if you're going from bottom to top, at the bottom it begins at -7. At the top it ends at +2. And I'm just going to write bottom to top to help us remember. You're talking about the range, which are the y values. Now you just have to figure out what kind of symbol should we use, a less than or equal to or a less than symbol, because you're only restricted to a less than or equal to or a less than symbol. You're not using greater than or equal to. So when I go to my y value at -7, all of these values above are greater than or equal to, but we're going to say -7 is less than or equal to y, which is also less than or equal to +2. So those are the two symbols you would be using since there are closed circles at both of those numbers. Now let's look at another example. Here we have a quadratic function and we're going to look at the x values. And since there are no arrows at the end of our graph, we cannot say the domain is all real numbers. So let's look at the x values from left to right. So from the left side of our graph, they begin at -3, and all the way to the right side, they end at +2. Again, if there's an open circle, you know that's going to be a less than. If it's a closed circle, it's going to be a less than or equal to. So we've kind of set up our inequality already. Domain is always from left to right. On the left, we begin at -3. On the right, we end at 2. Domain is x. And at -3, it's a closed circle, so it's a less than or equal to. At 2, it's an open circle, so it's a less than sign. So this means in words, all real numbers greater than or equal to -3 and less than 2. For your range, you're looking at the y values, and you're always looking from the bottom to the top of your graph. So when I go to my graph and I look at the very bottom, the bottom of my graph begins at -5 all the way to the top, the highest point. So here, they end at positive 4. At both positive 4 and negative 5, they are closed circles, so I know I will be using a less than or equal to symbol at both of them. So at the bottom, I begin at negative 5. At the top, I end at 4. I'm talking about the range, which are the y values, and both of them should be less than or equal to because they are closed circles. All real numbers less than or equal, greater than or equal to negative 5 and less than or equal to positive 4. So make sure you know how to say that in words. One more example. Here we have a parabola, and since there are no arrows at the end of my graph, I cannot say the domain is all real numbers. So I need to look from the left side of my graph, which begins at negative 4. It's a closed circle, all the way to the right side. So this is a little difficult to tell, but this is the origin at 0. And so this would be at positive 2 on the x. So again, this is another closed circle. So from left to right, I'm going to have negative 4 to positive 2. X is domain. And at both of these are closed circles, so it's less than or equal to for both of the symbols. All real numbers greater than or equal to negative 4 and less than or equal to 2. Now to find the range, you look from bottom to top. So from the bottom of your graph, it begins at negative 1. So both of these begin at negative 1. All the way to the top of your graph. The top of your graph ends at positive 4. Both of these are closed circles, so at 4, it's less than or equal to. At negative 1, it's also less than or equal to. So from bottom to top, you're going to go from negative 1 to positive 4. The y value is in the middle because you're talking about range. Both of them have closed circles, so they are less than or equal to and less than or equal to. So all real numbers greater than or equal to negative 2 and less than or equal to positive 5. So know the difference when you see your symbol. It says less than or equal to, but it's all real numbers greater than or equal to negative 2 because we're talking about y, which are all the values in between negative 1 and 4. Okay, the last example we're going to go over are some applications. So when we look at an application, you want to identify the domain and range as well. So here, if I'm looking at the domain, I'm looking at the x values from left to right. So if I'm looking at the x values from left to right here, my graph begins up here. But I want to recognize that the x value here is at 0. So they begin at 0 and they end at 3.5. So my domain from left to right is going to be from 0 to 3.5, and both of these are closed circles, so I will have x in the middle, and both symbols will be less than or equal to, from left to right. So in words, this is all real numbers greater than or equal to 0 and less than or equal to 3.5. Now let's find the range. The range when I'm looking at this graph is going to be from the bottom to the top. So if I look at the very bottom of my graph, this y value is also at 0. So this is the bottom, all the way to the top of my graph, and so the top of my graph will end at 30. So if the range is going from bottom to top, the bottom begins at 0, the top ends at 30. I'm talking about range, which are the y values which go in the middle. At both of those points, they are closed circles on the line and on the line, so they are less than or equal to symbols for both. So this in words would be all real numbers greater than or equal to 0 and less than or equal to 30. So if you're talking in description of this word problem, this is the height of a diver. So the height of the diver begins here in between 24 and 26, which is 25. So the height begins at 25. When they jump off, they reach a max height of 30, and then they hit the water after 3.5 seconds. So understanding that as an application is important as well. And our last example we will look at is the height of a rocket. So this time, the height of a rocket is going to begin here at the bottom at 0. So for your domain, you're looking at your x values. Here, x is t. So you're looking from left to right. And this is a dashed line only to show that it's descending, but it's really closed. We're including all of the points on this line, okay? So if your graph is going from left to right, from 0 to 8, our domain would be from 0 to 8. X goes in the middle. Both of these are included on the line, so they're less than or equal to. Again, from left to right. So all real numbers greater than or equal to 0 and less than or equal to positive 8. For your range, you're looking at your graph from the bottom of your graph. So this is your bottom. It begins at 0 for the y values, all the way to the top of your graph when this rocket explodes. So at 80, this is the top of our graph. When you're looking from the bottom to the top, at the bottom we begin at 0. At the top we get to a max height of 80. You're talking about the range, so those are the y values. Both of these are at closed circles because they're included on our graph, so it's less than or equal to for both. So all real numbers greater than or equal to 0 and less than or equal to 80. So now you're going to begin practicing on your own in your slides.